pause this video and see if you can solve this AP calculus problem. Let me know the answer in the comments below. Are you ready? Let's go. Okay, so what we have here is a particle's motion is described by the parametric equations x of t cubed, this one and this. So when is a particle is at rest, what is the position? So these are, we recognize that these are parametric equations, and at rest is when the velocity components, both components velocity is equal to 0, both x and the y components of the velocity of this particle in a curve, both the components of the velocity have to be equal to 0. Also recognize velocity is the derivative of the position function, okay, with respect to time. So derivative with respect to time. So we the x component, the derivative is dx by dt, and for the y component, for the velocity, it's dy by dt. Okay, so two components, as you have a particle in a parametric curve, the x and the y component of velocity is the derivative of the position. Now we're going to find the derivatives. So x of t is given by this. So what's the velocity is the derivative of this. Okay, so derivative of t cubed minus 3t squared plus 2, we're going to use the power rule. So 3 comes in front, 3t squared minus 3 times 2, 6t, and this 2 is 0. It's a constant. See, 3t squared minus 6t is the x component of the velocity, and similarly the y component is given by 2t squared minus 8t plus 5. Use the power rule again, so it's 4t minus 8, okay, of differentiation. So now next is we're going to set these both x and y components equal to 0. Remember, the particle is rest, x and the y component of the velocity is going to be 0. So let's take common here, 3t, and then we're going to t minus 3 minus 2 equals 0, and then 4 common. So t value here is 0 or 2, and here you take divide by 4 on both sides, t is going to be 2. So we have to find a common t value, okay, between the x and the y component of the velocity. So the common t value is going to be t, or is value is 2. So we're going to use this t is 2 when both x and y component of the velocity are equal to 0 and the particle is at rest. So substitute t of 2 back into the original parametric equations to get the position of our particle. Okay, so the first one was t cubed minus 3t squared plus 2, and we're going to substitute 2 here, so that's 8 minus 3 times 4 is 12 plus 2 is equal to negative 2. And for the y, we're going to substitute 2. 2 times 4 minus 8 times 2. So that's going to be 8 minus 16 plus 5 is negative 3. So the final answer is the position is going to be, so we have to know when it's at rest, the position of the particle is going to be negative 2 and 3, the x value and y value. Okay. All right. Let me know in the comments if you have any questions. I'll talk to you next video. Have a nice day. Bye.